you may have heard about generative AI and have been maybe playing around with ChatGPT, thinking about how this could impact the way that you program, the kind of programs you make, kind of apps that we take on. And in particular, you might have a background in web development and are thinking about making a generative AI app. Well, today I'm going to walk through making a simple collaborative storybook app where you can create different prompts for different chapters in the storybook, and then you can generate images to go along with the story. So in this example, we've got a little story about a monkey, and so I can say George was a dog. And in the background, my app will go regenerate all my images to update and reflect the fact that George is now a dog and is no longer a monkey. So today we'll walk through how to create this app and in general how to think through generative AI app building. So here we go. There's George the dog, and here's the elephant, and there's George asleep at the end of the day. So anyway, building an app like this involves thinking through using models and prompts and how to integrate those things into your app. This is all new to me as well. This is the first one of these I've built, so I'm going to walk you through it today. This is going to integrate some technologies you probably heard of, OpenAI. It's going to integrate stable diffusion for image generation using the replicate service. It's going to use LangChain, the LangChain library in JavaScript, in order to combine models to get in prompts together. And it's going to use Convex to store all of the backend data and do the backend computing, backend processing. Who is this for? This is really for anybody that kind of knows front-end development, that knows web development. You don't really even need to know a lot about full-stack development, and you definitely don't need to know anything about AI development. We'll kind of walk through together the thinking I did when I put this together. I'll share that all with you as we go. So without further ado, let's dig in and get started. We are starting with, this whole thing is going to be in like 4 steps. The first step is just a front-end app that doesn't have any, it's not full stack at all yet. This app is running right here, right now. This is page 1, this is page 2. I have kind of this carousel view, and on the left is the image, is the chapter text. This is page 1, right? And I can just kind of edit it and hit enter, and it will update the state. And then page 2, similarly. We don't have any images yet because we haven't hooked anything up to an AI yet. So if we take a look at the code here, this is a pretty standard kind of React app with a kind of this structure called book data that contains a number of pages. And we are actually just statically using use_state to set up our pages. As you might recall, this is page 1, this is page 2. If we refresh, we'll go back to that state. And then we have these kind of callbacks like update chapter, where right now all we're doing is we're updating the state using setState to add a page or to change a page's content. So on our next step, what we're going to do is take this simple kind of front-end app without any back-end state, and we're first going to make it a full-stack app that where these kind of handlers, like the backing state and the ability to update it, is stored on a server somewhere, so that as we collaboratively, me and other users that all are interested in this collaborative book, change the book's content, it's shared, and everyone sees the changes together and the new generated images together. So let's move here from kind of step 0 into step 1. First thing I'm going to do is I'm creating this incrementally here so that there's going to be a GitHub repository that everyone can follow along, and we'll just do a step at a time. And that way, if at any point you're following along and you get lost, you can just and kind of see the finished product. So step one will be, let's take that simple front-end app and let's make it a full stack app. So I'm going to kind of reinstall my node modules here and pop this app back up and just make sure it's kind of doing what I expect it to do, which is to be basically the same app. And sure enough, it seems to still be the same app. Cool. All right, great. So next move is to have some kind of backend that this can talk to. So that involves a database, some kind of maybe backend functions in order to push data in and out of the database. We're also going to use the backend because we are going to be talking to AI services. And those AI services are going to require us to have like an API key that's associated with an account. And so we don't want to like ship that API key in our web app. So we want a secure environment like the backend environment where we can store that API key and call those API services from the backend basically. So we'll use the backend for all that kind of stuff. But since we're just at step one right now, all we really want to do at this step is get to the point where we're not using AI yet, but we have this same app we have here, but this the book contents are actually being stored on the server. So first thing I'm going to do, because I'm using Convex to do this, is I'm going to create a Convex project. So I'm going to say npx convex dev, which will kind of kick off the project configuration. I'm going to say this is going to be a new project, and I'm going to put it in my company called Jamie Co. That's me. I'm Jamie. And we will call this just storybook, AI storybook. Let's call it that. And it's going to save a couple of variables to my .env file so that my app knows how to find my new backend. So this is kind of setting up a new backend, and we're up and running. So right now, not much is happening because I haven't actually written any code, but what I can do if I want to see my backend right now, I can check on my deployment by saying npx convex dashboard, and this should pop up in my browser here, a development deployment. This is kind of the one I'm iterating on right now. I don't have any data. I haven't stored anything in my database. I don't have any functions yet because I haven't written any functions, but I at least know that there is a deployment here up and running in the cloud that's ready to run my stuff for me. So let's go back to the app and think that through. So I'm going to keep it pretty simple. And let's see, I have a book, and the book has a number of chapters in it. So what I'm going to do is, first thing I'm going to do is I'm going to create I'm going to go into my schema here, my Convex schema. All of the Convex backend functions and schema definitions and everything is stored inside this folder called Convex. It's at the top of my project. So there's a TypeScript file here that defines the schema for my backend tables. And I am going to create a table called chapters. And the chapters has a few fields. The chapters table, define table, and then these are the fields in the table. So page number is going to be one of them, and that's just going to be a number. And by saying v.number here, this is convex values. I'm saying what the kind of type of values are that's being stored in each of these fields. Page number, the content is a string. So there's a page number and a string. And then, because I am eventually going to have images, there is going to be an image. And we're going to race ahead a little bit. And actually, for right now, I'm going to say that this is null. So let's just say it's null for now, because I'm not going to be generating images. So that's probably good for now. Anything else I need to specify now? I think that this is probably good enough to start. I actually, you know what? I'm going to add an index to my table because I'm going to look things up by page number quite a lot. So I'm going to call this by page number, and it involves the field, and you can see it's auto-completing here. It's saying which one of the fields that you defined do you want to use, and I'm going to use page number. If I wanted, I could specify multiple fields in my index if I want to have like a nested index, but I'm not. It's a very simple index. I'm just indexing these documents by page number. Cool. So now in the background here, I actually want to run npx. I am running convex dev here. So schema validation is complete. And as I modify all my backend functions in my schema, this will kind of just keep updating in the background. So back here on inside my project, I've got my functions and my files and all that good stuff. So let's take a look and see what is the first thing we want to do. We want to save the chapter. So you may recall that I said there's these little places that we're supposed to update stuff. So and these are really the only parts of the app we really should change. We're not going to spend that much time in the app. The front-end app, you can go look at it on GitHub. It's pretty straightforward React app, as I said before. But update chapter is now going to need to do something with the server because we want to save the chapter on the server. So I'm going to make a file called chapters.ts, and this is actually going to contain my functions where I store my chapters. So the easiest thing to do here is say, let me have a function called update chapter contents. So const update chapter contents, and this is a mutation. So and then from let's see, generated and server. Let's see it, make that happy. So I'm going to create a mutation, and a mutation is a function that can change data. So since update chapter contents is going to change data in my database, this is a function that's going to run in my deployment on the Convex backend that can change data. And it takes an asynchronous function that contains a DB object, and this lets it change things inside the database. Now, what are the update chapter contents? Well, as you'll recall here, there's a page number and there's content. And then I also have this schema where I have a page number and content. And then I'm going to have an image eventually, but I'm not yet because we're not using those AI services yet. So inside chapters.ts, let's make sure we take those arguments. So page number is going to be a number. Oops, page number. And contents, and that is a number. Contents, it's going to be a string. And let's say db.await, db.insert into chapters. Yep, see it auto-completed there because it knew that table existed, and now here's my document. Page number and content. Oh, I called this contents. Let's change that to content. So I want to insert a document into the chapters table, including the field page number and content. And I'm getting an error. Property image is missing. Yep, it is. No images yet. Okay, cool. And that seems happy. So that's it. I've written this backend function. It takes the DB object, which is given to it by Convex, and gives it write access to my database tables. And it's inserting a document into the chapters table with these three fields in it. Page number, which is the given page number, content, and the image, which is null. So now inside my app, actually, you know what? Before we go to the app, let's take a look at what we have going here. So AI storybook. Yes. I was kind of wondering why this wasn't getting uploaded, but I think I know why. So I have to export this. So as you can see in the background, when I make that change, npx convex.dev automatically updates the new version of functions when they appear. And It's still not working. Why is this? Ah, okay. So this is because I'm in step 0, everybody. So let's jump over to step 1. So anyway, we're going to close this, and let's copy step 0 convex star.ts into this convex directory. Now let's run this and see what we have. And we want to open up code here. Okay. Okay, we're in the correct project now. So did this upload? It did. And look, we have an index added. And now if we come over here, oh my gosh, what do you know? We actually have our function uploaded into the backend, and we have a chapters table. Cool. Let's try this out. See, we're going to make mistakes on the fly here. I was in the wrong directory. So now we're in the right place. Inside of Convex, we can actually try this out to see how it works. So we can say run function, and we'll see page number is 0, and content is, this is my content. Let's see if we run this. It returned null, which is kind of what we expect, and it ran successfully. So over here in data, you can now see we have a document in our chapters table. So content, image, page number 0, etc. Cool. Okay. Great. So we are inserting data into our backend. Now, let's query data. So let's do something like, let's call it get book state to grab all of the pages out of the book. Let's ignore the Git repository for now. So export const, we're exporting this time, get book state equals query. So mutations are how we change data in Convex. Queries are how we retrieve data in Convex. So I'm going to import query, and then we'll make sure, yep, we have it there. And we also toss a function to this, an asynchronous function. It also takes a database object and returns whatever we want. So in this case, we want to return, let's put a type on here to keep us honest. So we're going to import doc, which is automatically generated from our data model. And as you can see, it auto-completes chapters. So we are going to return an array of documents from the chapters table. We don't have to spell out what the fields are in the chapters table, because by using this doc type, it automatically knows. And that way we can go implement our query function here. And if we don't get it right, we'll get a type error, and TypeScript will help us out. So, okay, cool. So if we want to grab all of the pages and we want to grab them in order, let's use that. Let's write a query here that uses the index. So const pages equals await db.query, and you can see it auto-completes chapters. Again, our one and only table right now. And then with index, and it auto-completes. We have by creation time or by page number. By creation time exists on all tables automatically. They're indexed by creation time. And dot collect. So the reason why we are retrieving these pages using that index is this makes sure that we get them out in the page number order. That way we know the pages are all returned in order. And at this point, if we say return pages, we're probably good. That's right. I can't say doc. I need to say, let me make this bigger so everyone can see, including me. This is promise. This is asynchronous. So there we go. All right, no errors. You can see in the background we had that same error when Convex tried to push it up to the backend. Now it succeeded. And let's try it out. So as you all saw a minute ago, the dashboard is a really useful way in Convex to check that things are working. Inside of the chapters module, we have update chapter contents in get book state. This is the one we just wrote. The type checked and got uploaded. Let's just run it. It doesn't take any parameters. Oh, and you can see it already returned the result, which is one page, the one page I put in there, with the content. This is my content, and page number 0. Just for kicks, if I duplicate this and we come over to another window and we want to run this function again, let's see if I can compress this down enough to get to the, here we go. Page number is 1. Content is, this is page 2 content. If we run this, you can see immediately over here, the query is updated to reflect the latest results. And so everything is kind of reactive like that in Convex. So we now have in our table, we have 2 documents. Great. Okay, we're done writing backend functions for a little while. Let's go back to our app and make this actually like hook up to this so that it's a little more satisfying than just using a dashboard. So inside of our app back here in app.tsx, as we mentioned, we have this this use state here, and this represents the book state. And here's book data. Now you'll see when this was just a front-end app, I had this page type here that I defined so that I could, you know, scaffold this up correctly. But as you might recall from what we just wrote in our backend functions, now we can just make this, we can use that magical doc type to make this say whatever the type is in the schema file for Convex, that's basically what we want here. So we don't have to repeat code. We can basically say now pages is going to be doc. Nope, not that doc. Let's see if we can get the right doc. Let's see. Sometimes importing gets confused from Convex generated. This is going to be data model maybe? Let's try that. I think that's right. Yeah. Okay, cool. All right, so pages, there it is. Now, doc, chapters. It's just like we said on the query that we wrote over here in chapters.ts, where we're saying the return type is promise of doc chapters, and it's an array. Yep. Make this like a little wider. That's the same type that we want over here. And as long as we do this, we have end-to-end type safety. We know we're getting the right thing. So now we've got these bugs to go fix, and we're going to fix those by attaching this to backend state. So use state, we no longer need this, right? You can see right up here, we have, let's write this out. Let's get rid of that and just write it out together. So const pages is no longer a local set state. It's no longer a state, React state variable. We're going to use query from import from Convex generated React. So there's this hook called use query from Convex, and yep. And you can see it auto completes with it knows what queries exist on the back end, and it just puts it in there. So this doesn't take any parameters. So all I have to do is say use query pages, and it should automatically hook up to our backend state. Oh, you know what? I haven't finished configuring Convex here. So now that we have a Convex project, we actually need to import that the URL to be able to get to our to be able to connect to that deployment. And then we need to use the Convex provider, wrap our app in a Convex provider so that Convex knows where to find equals Convex. All of this is in the Convex docs, and in fact, if you download most projects, they do this for you, but since we added Convex later, I have to just fill that in. Okay, cool. Now we should find, yep, there you go. This is my content. This is page 2 content. Cool. And by the way, if we come over here, because again, everything in Convex is reactive, and we change this and say page 2 is the best, and we hit enter. Oh, there we go, because that's actually page 1. All right, let's change it this way. That's good. Page 2 is the best. No, Page 1 is the best. All right, watch it over there on the left. There we go. Page 1 is the best. Cool. So we now have our app hooked up to the backend state. We are using a query to attach the contents of this table. And remember, that query is chapter get book state. We are taking this function here that we wrote, and it is just returning the contents of that chapters table, which we can see right here. And whenever this changes, our app will automatically update and populate our state variable in React so that the app redraws. Okay, the query side's done. Now we need to make it so that when we actually change the data on this app, it actually updates the backend table. And to do that, we are going to use this mutation that we wrote right here. Update chapter contents. So let's go back to our app and make that side happen. All right, so in our app, we've got some fun errors that are probably related to this. Yep, update chapter. It's got some errors in here because it's trying to update a local state variable that just doesn't exist yet. Pages is no longer a set state, thing. So let's rewrite this. We actually, I think we probably don't need this whole thing. This has the same type signature as the mutation itself that we wrote. So we can just say use mutation, and then you can see this once again auto completes it. It remembers that is the mutation that we've written inside of our convex directory, update chapter contents. And yeah, so if we do that, then we can hover and see here, update chapter is a React mutation. We're passing it the right page number entries. Our entry.image is possibly null. Our entry.image equals null, else. Oh, this is TypeScript, maybe just not completely understanding the semantics of, whoops, our image would not be null if we got here. Okay, we'll make those go away. Oh, our entry is possibly null. Interesting. Anyway, I'm not going to spend too much time on this right now. Let's wait until we're actually generating images, and we'll find out if this is actually a problem. As far as I can tell, there really shouldn't be circumstances where this happens. So, okay, cool. Page 1 is the best. We're not getting errors about our mutation stuff back up here where we say update chapter. Okay, so in update chapter is being called, and it's directly bound to this mutation. One more time, that mutation's over here, and it's inside of our convex that's being uploaded in the background by convex dev out of our convex folder right here. Okay, so probably it works. Let's try. Page 1 is the best, I promise. And it didn't work. Let's find out why. So if there's ever an error inside of when you're working with convex, you can, oh, there's a 500, interesting. Failed to load, the server responded with 500. Oh, it's failed to load resource. Let's refresh. Okay. I don't think that has anything to do with convex. Let's see. Let's go to our logs over here. And I'm going to make this a little bigger so that we have better visibility. Mutation update chapter contents was called, yeah, just earlier this minute. It says success. Oh, that's why. Okay. All right. Yeah, so this is a bug. So the bug is I'm always inserting a document with page number 0. We actually kind of want upsert type behavior here, where we check to see if it exists, and if it does, then we update it, and if not, we insert it. So first thing we want to do is say const existing equals await db.query. This is chapters dot with index, and then by page number. So we're going to use that same index, and dot filter, and then in convex we can say q dot equals, and then the let's see, with index. Yeah. Let's see. So yeah, so actually the range specification in this case is we actually want to do the filter on the index. So right here we'll say q dot equals, okay, and then page number is the field and page number. All right, and then we're going to say dot first because we're only expecting one document. So just to go over this for a second, we're going to use the by page number index, which we defined right here in our schema. And we're passing a predicate, so don't give us everything. Give us documents in that index where the page number field is equal to the given page number. And then dot first is a method that returns the first document that matches, or none if no document matched. So this, as you can see, is a document with page number, content, image, or null. So okay, cool. And let's not mark this const because we're going to actually update it. If existing not equal to null, then we do something. Otherwise, we insert. Okay, now we probably have the right logic here. And our problem is we inserted duplicate pages with that page number. So, all right, so now in this case, we can say await db dot, I'll use the patch method, and it takes an ID. So the existing document has an ID field on it. And then we want to update one field in it, which is we're going to say content is the given content. We don't even have to specify it twice. Okay, so if there's already a document, update the content field. Otherwise, insert a new document. Okay, now I think we maybe have it. Uploaded successfully in the background here. Let's try again. This is page 1. Okay, so that seemed to load this. Oh, I got a typo there. This is page 1. Okay, so here's our dashboard. Yep, this is page 1. Let's change it pretty dramatically so we can watch. I'll hide our dev tools for a second. This is page 1. Let's say it. Page 1 is the best. Yep, and you can see in our table in the background it updated. Okay, cool. We now have connected our front end and back end. So if we add another page, page 2 with empty content, we'll scroll down to it and say page 2 is even better. And over here in our back end, we've got pages. As you would expect now, if we refresh, we don't lose all of our state. We actually keep the back end state. And if we open it up in another window, probably none of this is shocking, but once again, it's all in the same place. Page 3 will be amazing. There we go. You can see it. They all stay in sync. Cool. All right. So we're done with the first step, which is we have connected the front end app to a back end. So where do we go from here? Well, what we're going to want to do is every time we change the contents of a page, we are going to want to kick off, if we want to generate an image that goes here on the right for that page, we are going to want to kick off an API call to some generative AI services. And so in that mutation, when we change the page content, we probably want at that point to do something that will start to ask an AI service to make an image for us. And then when it's done making that image, we want to update our app here to give it the URL to where to find that image. And then the image would populate, and then we would have a book with pictures. Okay, so I'm just talking it all out, but step 1 is done. Step 2, the challenge is let's introduce an AI service and let's figure out how to get it integrated with this thing that we've started to build. All right, I'm going to take a short water break. I'll be back in just a minute. So step 1 done, full stack app. Great. No pictures. Let's start solving this. So step 2, we're going to introduce our first bit of basic AI here. And what's interesting is that even introducing basic AI isn't that basic, actually. There's a fair amount of stuff we should talk about and think through. Yeah, let's dive into that here. All right, so sketch out some ideas, think this through, do some planning before we dive in. So what we mean is, just to get concrete here again, that every time one of these pages changes, specifically when the content changes, we want to kick off a job to turn the book content, and in particular the book as it's taking place on that page, we want an illustration that accompanies the page and is going to show something appropriate for like a children's book, which is the framing that we have here. So the simplest version of this is, first of all, we should talk a little bit about image models. For the images, I'm going to use a service called Replicate. And Replicate's pretty cool. You should sign up, go check it out. It has a ton of models in it. You can hit Explore and check out all of the different models that are available to you. The one that I played around with and ends up working the best for this project, for our storybook, is actually this Kandinsky one. And one of the reasons is that the illustrations look a little bit more like illustrations rather than photorealistic. We're not really looking for photorealistic here. And so the first thing I did before I even began any of this is I actually just came to the website, whether it's OpenAI or whether it's Replicate or anything like that. They all have kind of an explorer. You should come to the website, grab a model, and start playing with prompts until you get a sense of what you're looking for. So in this case, I started like, this isn't just sample data. Let me now start to have a real story. So let's say it's about George, and he's a monkey, and he goes to the zoo. Like this was the very simple story I was playing with. So we might have something like page 2 when he's at the zoo, or we say something like George the monkey is at the zoo. But even that, if we think about the kind of prompts that we actually want to give image generators, they don't care that the monkey's name is George. It's not relevant for what they're drawing. One of the things you find out pretty quickly is you want to give it relatively simple instructions that are pretty straight to the point. So let's do something like this. Let's say a monkey at the zoo watches the elephants in their enclosure. Okay, let's kick that off and see. So something like this might be the right prompt to get a reasonable output in the second panel. And so you can see here we have a monkey, we have some elephants. Those things in the background are kind of elephant-esque looking. We'll call them elephants. And the thing is kind of monkey looking in the foreground. You'll find generative AI is pretty funny because you get a lot of things where like the broad strokes are right, but the details are not quite right. But that's a lot of the fun of working with these things. It's just a lot of tuning you can do. But this is like a decent starting location. So we really want pretty simple descriptions like this if we want an opportunity to have the model generate something reasonable. And so let's use Replicate and let's use this Kandinsky 2 model. The library I'm going to use inside of my application is a library you may have heard of called LangChain. And one of the reasons, there's a few reasons to use it. One is it's just kind of like widely known and supported. So if you learn it, you can use it for a lot of different things. It's very flexible. We're going to use it in more powerful ways in step 3. But even just if you're doing something simple, one thing that's kind of nice is it's one library that kind of consolidates access to a lot of the major like model services out there. And so you can get to OpenAI, and you can get to some of Google's stuff, and you can get to replicate via one library. So LangChain is a pretty good thing to just import and kind of start your kind of generative AI project with it as your, I would say, kind of central library to build your workflow around. And as I said, when we get into step 3, you'll see why that becomes more important. Things seldom stay simple when you're doing generative AI projects. So coming back over here, every time this changes, we want to go generate another image. Now, when I said things get complicated right away, let's talk that through for a second. So one thing that we have to contend with is this sort of grim reality that generative AI is very new. And so it has a few characteristics associated with it. One is, you probably remember from the beginning of the video when I demonstrated the app we end up with, it's relatively slow to run. It's pretty expensive to run. And not only is it expensive in terms of the time you'll wait for it to be generated, but it actually is expensive in real dollar terms as well. So when you sign up for these API services, these AI services, you're probably going to find you need to put a credit card in and have a paid account to at least spend a few dollars a month iterating on your projects, because it does still require a bit of compute time on their end in order to make these things. So the reason why that matters to us is, you may have noticed, and we'll do it now, that I opted to have a way of interacting with this where here, let me make sure that we're up and running here and everything is. So yeah, let's dive into this real quick. So we're now in step 2. Let's make sure we've got everything installed we want. And let's run dev, and let's also npx convex dev so that we've got convex synchronizing our backend stuff as well. Okay, so yeah, so now we synchronized here. So real quick, let's see the choices I made here. There's a little bit of a delay before we propagate changes here. You notice as I move around and do stuff. However, if I pause for a few hundred milliseconds, content on the right updates. So, and one of the big reasons for that is it provides a pretty fluid experience, multi-user experience to like update stuff. Similarly, if you make a text change and you just close the browser, you're pretty likely to have propagated to the back end. So I don't wait very long before mutating, basically before calling that mutation we referred to in the last step. That's great, but here's the problem. If every time the content changes, we kick off a call to, let's say, replicate, to do like an 8 to 15 second image render, we're gonna run out of quota really fast. We're gonna spend a lot of money. So there's a little bit of there's a pattern that folks may have heard of, which is kind of called like debouncing, right? Where when like an input happens over and over again, like you kind of have a signal like this, you basically kind of wait for idleness before you actually kind of trigger the activity. So in this case, each one of these kinds of events is like a mutation, and we sort of wait until the mutations have stopped for a while before we go and generate the image. So we really want to make sure to save partial results and all that kind of thing. But one of the things we also want to make sure we do is that we wait for some kind of stability before we go and invoke the AI service, because again, it's expensive and everything else. That's one. The second thing is what happens if this occurs. So this is time this way. Apologies for the terrible scrawling. So I actually should use a tablet here. Let me see. So this is time, and these are like mutation events, right? So The issue we could run into is that we kind of kick off this expensive AI thread here. And let's see, right here. Oops, there we go. So we kick off a kind of AI activity here that's running for a while. But while we're doing it, another mutation comes in here. And so the issue we have is that, let's say a single mutation comes in there, and then like 3 seconds later, and then after that seems stable, we then kick off another AI thing. The problem is that this first AI thing we kicked off could finish and come in and write the image result to the database, but it's no longer the same content, right? So at this point, George could be a monkey. We wait for it to be stable. We kick off the AI thing. It takes 10 seconds for the AI to run. And then by the time it's done, George is now a dog. And we update the image to show a monkey. And that image is no longer relevant because the world has moved on. The book isn't about a monkey anymore. So we basically need to account for this, right? It's kind of interesting that we run into complexity like this so early, but this is the kind of thing you're going to run into if you want to have an app that actually does the right thing, that actually works, and you have like long-running asynchronous stuff happening in the background. So the good news is Convex has pretty good facilities to handle this, but it does mean we're going to have to be a little bit more aware of this challenge early on. So this step is mostly going to be about introducing replicate the service to generate images using this model, Kandinsky 2, and just getting a little bit of state management going in the back end so that like we're only updating the image when it's reflecting whatever the current content is. And we're also kind of debouncing the changes a little bit so that we're not kicking off like 15 image generations in the background and none of them are going to end up mattering because the content has moved on. So hopefully that all makes sense. Let's dive in a little and tell how we're going to handle that now. I'm going to pull up VS Code and I'm going to make extra sure that this is step 2 and not step 1 so that I'm not making changes that aren't being updated. And probably the first thing we're going to do, I'm going to do here is I'm just going to add a second table here, and I'm just going to call it version. Okay, so it's going to be another table, and it's just going to have. It's not going to be with the chapters. It's going to be outside of the chapters, and it's going to have basically one field in it, and the field is just going to be the version. So it's going to be a v.number. And that's it. So why is this unhappy? Cannot find name version. Do you need to find name version? Aren't I telling you that your name is version? I'm not quite sure what that means, honestly, offhand. Define oh, of course, it's not in curly braces. Yeah, that would make sense. Okay, there we go. Okay, so over here, we have a new schema. Let's just come over here real quick. Oh, version, the table's there. We don't have no data yet, so all good. So before we even get into the AI thing, I'm going to just get ready for this problem so that I don't kick off a bunch of AI jobs for no reason and have them shut down my API key. I won't say that that hasn't happened to me, because it has. Well, learning a lot of these lessons the hard way. So cool. So when we update our chapter, I'm going to make a little helper method here called bump version. And it is going to take a database writer object. And what it will do is it is going to grab that version. And you know what I'm going to do? I'm going to cheat right now just to save us some time, right? I'm going to just put the first document in there. That way I don't have to code the upsert pattern. So the document will always exist. And I'm going to do a really similar pattern you saw me do with patching below. So I'm going to fetch the existing document. So in this case, I can say const version doc equals await db.query. And now I have two tables, so it's not always autocomplete the chapters. db.version.first. Okay. Oh yeah, this is async. That's why it's complaining about the await. There we go. So this should always be there, basically. So we're going to shorthand. You should have better error handling in a real app, but it's fine. Cool. So then for the version doc, what I'm going to do is I'm going to say version doc.version plus equals 1. Actually, again, if I'm just going to use patch, then I only have one more thing to type. db.patch. Okay, you might be wondering, by the way, why does db.patch not need to take the name of the table? And it's because in Convex, IDs are globally unique, so all you need to do is pass a document's ID, and Convex knows what table it's in. There's no need to specify the table. So we have the version doc. We're going to pass the ID, and then we're going to pass the fields to update. And the only field we want to update is version, and we want to set it to version doc.version plus 1. So check these here, but or undefined. Well, why would it be undefined? Version doc is type doc. It says or null. Yeah, it's I promise. I promise it's not null. Okay. So we have a little helper function called bump version, and every time this gets called, we are going to bump the version. Let's just put it down here at the bottom. Await bump version, and we'll pass it along the database object. This database object that our mutation's given is a DB writer. A query could not call this because queries can't mutate. So they have a database reader, and database reader does not satisfy the type database writer. So we got our type checking. It's keeping us safe here. All good. So now what we'd find is, let's test this real quick. We just wrote this. It already synchronized it up, all the usual things. Page 1, this is a good thing to try. Let's add another page, and the version got bumped to 1. So one of the things that you might be wondering about is we have one, the document gets either inserted here as it did just now because it was a new page, or updated. And then we have another operation that is updating this version inside the version table. What if only one of those happens and it like the function fails around here? So mutations in Convex are ACID transactions. So it's guaranteed that both of these things occur, or none of them do. So it's okay for us to kind of write it this style and just assume the right thing will happen. So yeah, so now we're all good. Every time we change any page, we are updating this version field. So this version really represents the version of the book. It's the state of the whole book. And so if any page changes, we actually want to invalidate all of the actions that are running. Does that sound right? It will, yeah. Right now it sounds kind of weird probably, right? You're thinking we maybe want to have a version per page, because like if I only change one page, I don't want to change the other pages. The truth is, what we're going to run into in step 3 is that we actually do want to rerun everything if any page changes. So let's just build it this way for now, and we'll dive a little bit more into why later. But what this does mean is every time we change any page, we want to reschedule API calls for every page, right? Because we're basically invalidating any API calls that are currently going. So we want to kick off brand new API calls for all pages in the book. Anyway, we'll make this all concrete right now. So what do we mean by that? So I mentioned when we were kind of sketching this out, we're going to have these long-running asynchronous things, which are these calls to API services. So in Convex, we have, queries like get book state, which are read-only and automatically cached, and they reactively update and all that fun stuff. They have a cache. You can see the cache hit rate here. Mutations, which change data, but they're like ACID transactions. Because they're ACID transactions, they can't do any side effects. They're not allowed to call APIs. They can't write to file systems. They can just be a fast, kind of deterministic, basically, function. When we want to do, and they need to finish pretty quickly because they kind of run inside the database, basically. When we want to just like call a bunch of services and use a bunch of code, there is a way in Convex to do that, and it's called an action. So in the same way we write queries and mutations, we can write actions. So I'm going to make our second Convex file right now, and I'm going to call it ai.ts. And this is going to be the file where we put all of the kind of like, hey, go do something, and with third-party services, right? And specifically, this will be the place where we do all the stuff with these generative AI services. So the first thing we're going to do, as I mentioned before, is we're going to use replicate in the Kandinsky model, and we are going to inject images. So let's first just make an action that does anything. So this is something that can have side effects, and it can be scheduled either by a timer or by a mutation or whatever, or it can actually even be called directly from the browser if you want it to be. So in this case, let's just start by just defining it first and just get our feet wet here. So let's call this something like populate page image, okay? And this is, let's export it so we don't get caught by that. This is going to be an action. It's just like query and mutation. Action is a function that you give a callable that is a asynchronous callable. And for now, let's not have it take any arguments. What can we do here? Let's just do this. Hello from the AI action. We're just have it console.log. Okay. We don't have any errors. If we come over here, we can see AI populate page image, and it's marked an action. Okay, cool. We also are going to pull in lots of libraries that have complex dependencies and do randomization, and basically aren't deterministic. They have side effects. And so we need to be in the node runtime. And so in Convex, if you put use node at the top of the file, it will make sure the action runs kind of in a full node.js runtime. And this is instead of running by default, queries and mutations run in something we call the optic runtime, which is like a very high performance embedded JavaScript runtime that runs inside of the Convex database. Use Node, you get the full power of Node. It's a little slower to start up, but you can do anything you want, and you can run for minutes, right? So that's kind of this module. We want all the actions within it and functions within it to be running within Node, and we're going to use all kinds of libraries from NPM. So, all right, let's see how this goes. Just like any function, we can run an action in place. You can click logs, and we see hello from the AI action. Cool, we can test it out. Whenever we want to check anything, we can always come to our logs panel here. As I think I flashed to briefly before, you can see as opposed to these queries that are 1 millisecond, those are cache hits. Those are going to be really fast. Slightly slower queries that have to go back to the database and actually get the records. Actions take substantially longer potentially because you're potentially spinning up an entire kind of Node.js environment. They can be shorter than that, 100 millisecond, 200 millisecond, but these are going to be like, beefier, longer running processes, basically. Cool. So you can also see, though, that inside of our general logs, we also got hello from the AI action got logged. So anything, we've kind of created our hello world of actions here. Now, actions very often need to, before we dive into what actions do, now, if we go back to this view and we remember kind of the provocation to get here, our design conversation, we actually want to kick these off whenever things change. When these records are updated, it's time to go generate more images. That was what we said. So how do we turn that into code? inside chapters.ts, update chapter contents. This is our mutation that does the updating. So why don't we just do this? Let's update our arguments here, populate page image, and let's have it, this first argument is a convex context argument, kind of like it is with queries and mutations. We'll use some things from there in a minute. And the second one is this is our parameters for this action. So let's say page number, which is going to be a number. I almost put the type in line there again. And version. Okay, so page number is a number. Version is also a number. So if we talk this out, what we mean here is generate the image for page number n, right? Whatever this is, for page number 1. And this was kicked off when the book was version 5, right? So this version being passed here, this is the thing we're going to check to make sure, is the current action we're running still relevant? Does it still matter by the time we get the image back from the AI service? Is it still the same book? Or should we just throw the image away and it's wasted work, right? So we're going to hang on to this version throughout the run of this action so that we can manage this asynchronous problem about long-running actions that may finish after the book's been changed. So before we do anything else in here, maybe let's at least do this. Okay, we'll say hello from populate page image for page page number at book version. Okay, we've made this a little richer, give us a little more debugging information. Cool. All right, this is fine. Now if we try to call it over here the way we did before, we're going to find it doesn't work because it takes some arguments, and that's okay. So run function like this, it's empty strings at these places, undefined. So page number 0 and version 4. Yep, run action. Page 0 at book version 4. Cool. Okay. Still seems like we're good. Okay, now back to here. We want to kick this off when a chapter's changed, and we want to rerun it for every page in the book. So we'll really be just using a couple of one new thing here and then some concepts you know. So this context object can also take a scheduler. And in Convex, the scheduler is kind of a way to run things in the background, right? So you can run things after a delay, you can run things right now, but it basically means asynchronously, I want to run something, run it on a schedule, run it now, whatever. So let's use this down here. After we bump the version, the indentation here is like kind of bothering me a little bit. Prettier supposed to be automatically formatting this, but on this machine that's not happening, so I'm just going to do that. So let's say pages equals await db dot. The order we get them in doesn't matter here, so I'm not going to use the. I'm not going to bother with the index. I'm just going to say db.chapters.collect. And in fact, we actually just need the length, don't we? A bump version. Oh, okay. All right. Cool. So let's do this. Promise number. Okay. Const new version equals. We'll bring this up there. Okay. This is what the new version is going to be. We'll assign it in the database, and then we're also going to return it. Okay. So now bump version returns the new version number. Const current version. So this is the new version after this change is applied to the database. So that's one of the two parameters we need. In fact, let's just call it version. And then finally, we need to know how many chapters there are. So pages is basically all the documents in the chapters table. And then we can just say for, let I equal 0, I is less than pages dot length, I plus plus. And obviously in JavaScript, there's like 4 different ways to make a loop, but I'll just use this one this time. Okay, scheduler await, scheduler dot run after delay milliseconds. Let's say wait 3,000 milliseconds just to see if it's still the same version. Maybe even 5,000. So let's wait 5 seconds. And then after that, you can see we have our autocomplete to the rescue here again. So you can schedule either running mutations, right, later, or actions. And in this case, populate page image, the action, is what we want to run. Why can't you run queries later? Because they're read-only. If no one's listening, it doesn't do anything. So there's no point in asynchronously running a query. If you think about it for a minute, it kind of makes sense. So, all right, we want to run this action in 5 seconds, and then it takes some arguments, and you can see those are auto-completing here too. So the page number is I. So page 0, page 1, page 2, however many pages there are. And by the way, we're kind of using 0 indexing for page numbers here. It's, we're doing the programmer thing. And then the version is version. Okay. So let's look at this one more time. For every page in the book, since we just changed the page in the book, we want to regenerate all the images for the pages in the book. And so for every page there is, kick off, schedule a background action to run in 5 seconds for each of those pages, and pin it to the current version of the book in the database. Okay. Now, I'm going to make one change here. Well, first, let's see this. Let's see this happen before we do anything else. Okay. We just made a change. We got our little convex dev over here. Claims everything is still fine. Maybe it's lying to us. Let's see. So let's go to our logs and let's go to our app. And a change requires actions to run. Okay, let's hit enter and we'll notice a mutation. One mutation happened because it got updated. 2 queries ran up, and then you can see 5 seconds later, there's these 3 actions ran in parallel. Hello for page 1 at book version 2. Hello for page 0 at book version 2. Hello for page 2 at book version 2. Okay. So far, so good. So we are running actions in the background that run about 5 seconds later, and for all of the pages in the book. So now if those things went and talked to AI and said, hey, give me an image for this page and its contents, and the service gave it back a URL to an appropriate image, we kind of would just put that back into the record in the database, and then our app would be happy. So that's kind of what we want to do at this point. Let's give that a shot. So now we're going to get into the AI part of things. First thing we're going to do is we're going to go into get book state, and I'm gonna modify this because I actually want to use this same query from well, maybe I'll make it clean. I won't mess up our nice app. So let me just say const get book state with version. Okay, so we're kind of going to do something slightly icky here because it just kind of keeps things cleaner. We could have one of these call the other one and reuse them, but with version, and instead of it just returning a promise with the book page array in it, we're going to have it return a number and that. So now this is unhappy, and that's because we also need to get the version. And I'm going to make one more change to this. Because this is only called from the backend, it's best to just be conservative, and I'm actually going to use this called an internal query. And an internal query in Convex can only be called from your own backend. So it's a secure function, basically, that's not callable by the browser. There's no reason to expose this, so let's not expose it. It's not actually a security problem, but it's just I don't know, being clean, right? So, and then finally version doc equals, this is very similar to what we wrote in the other thing, db.query version, there it is, dot first dot version, well, we'll do that. And now to fix this error, we need to say version, which one did we return first? The number. So version doc dot version and the pages. Oh, that's not supposed to be a question mark. Stop doing that. There we go. Okay, so what do we do here? We created a new query. It can only be called from internal things like actions, hint, hint, and it is basically returning the book state, but it's also returning the current version of the book. And those things are, because this query runs in a consistent window, there's no race between these two queries. It's like it's the same. And so the action now is going to use this. So I mentioned we have this context variable here in convex actions, and it has a lot of things you have access to. One of them is run query. So you can kind of call over into queries basically from convex backend actions. So let's just leave that console log for right now. It kind of gives us a waypoint. We know where we are. Const version book equals run query, and there's our autocomplete, and you can see it autocompletes the internal query because we're in a privileged context. This needs to be awaited. I don't know why it's unhappy with, oh, that's because, yeah, we already have a version. Good. Current version, okay? So remember I mentioned the whole thing about let's handle this problem? So we schedule 5 seconds later, maybe run the action as long as the state is still the same and there hasn't been more debouncing. So there's going to be little red spots here where actions kick off, and they ideally should check right away, like, oh, I'm no longer the current state and I'm just going to exit. And then some future action that's going to run will eventually observe the idle state and will kick off, right? If we were being a little more accurate, that this should look, whoa, oh my God, that did more than I thought it was going to do. That's fun. This actually should look more like this, right? And then stillness here. And then this would kick off 5 seconds later and observe that the version had not changed. Hopefully all these little squiggles are still making sense to everybody. Okay, widen this, and we've got our current version. Now, if current version is not equal to the kind of given version that we were run with 5 seconds ago, then let's log this too so that we know that this is happening. Outdated, exiting, not existing. Let's just bail out, okay? Otherwise, would call AI services. Okay. New check. We got our functions. They're pushed up. Everybody's happy. Come our storybook. Let's make some changes. This, we're going to pause. There's an update. Is a change to the story. There. See that? So these earlier ones exited because by the time they ran, the version had been incremented. And then finally, when I stopped typing for a little while, we got to an invocation of the background action that would run because the version was still the same. So it's probably worth firing up a call to an AI service. Let's do that now. Time to call replicate. So once again, we're going to be using this model right here. What does the code look like to do that? Well, I'm going to show you. So let's first just write the rest of this function. Let's get the rest of the scaffolding ready. So export const update. Oh, one thing we should remember to do here is when we update the chapter contents, if there's already a document there, we want to reset the image to null. We want to clear the current image because it's no longer valid. The image might have been null, but it might have been a URL and an image record. And in that case, that's not it's not accurate anymore. The content has changed and the associated image needs to change. So update chapter image, and this is going to be an internal mutation, because we're going to change the database. Async function takes the DB object. What are the arguments? So page number, version, and what's the image actually going to represent? I take it back. Let's come back to this, because I think once we talk about what's happening in AI, it'll be clearer what we want to do here. Okay, we're just going to comment that out for now. So let's actually go call. So over here, what I'm going to say is const image URL and prompt equals await get page image for the book and the page number. All right. This is async. Okay. Book, and this is doc. Once again, this is our doc of chapters. Make sure those types stay good. Page number is a number. And this is returning string. All right. So this is probably the first opportunity we should talk about prompt engineering a little bit. It's a little bit of a doozy. So as you could tell just from what we were doing when we were on the replicate page itself on the Explorer, changing the prompt makes a big difference in the output of the image. And so what I want to set up already, and I think you're going to find the more you iterate on generative AI projects, I want to hang on to what the prompt was that generated the image. So not only do I want to hang on to it, but you'll see in the app, I actually am putting the prompt as the title attribute on the image tag, so that when I just hover over the image, I'm able to see the prompt that generated that image. And while you're in the iterative phases of doing AI work, making sure you're storing and easily making accessible the prompt that generated the image is pretty important, because you'll probably find you're iterating a lot on the kinds of prompts you're using. So that's why I'm already making sure that this page is kind of kicking back whatever mechanism it's using to derive the prompt, that it outputs that as one of the results with the same importance as the actual resultant image URL. We want to hang on to that. So that's part of why when we go back to chapters.ts, when we update like the image data associated with the chapter, we're going to include both the URL and the prompt and store those. So anyway, let's do the AI stuff now. Cool. So as I said, we are going to be using LangChain, and we are going to be using LangChain, replicate out of LangChain. So up here at the top, let's start by saying import replicate from, and this is going to be, I'm sorry, not replicate. This is going to be LangChain LLMs replicate. Okay. Now, there's three main things that we'll be dealing with for the rest of this video when it comes to, I'm sorry, I didn't show you the screen. When it comes to LangChain. So up here, you can see I imported replicate, and then I've got this get page image function I started right before, and we're going to start using replicate inside of it. So inside of LangChain, there are models, there are prompts, and there are chains. And then there's some other things as well. But these are really the three that we're going to be focusing on for both this step, finishing like step 2, and then when we get a little bit more involved in AI prompt engineering in step 3. So, but we're going to keep things pretty simple for this one. And by the way, I can tell already, this is complaining at me because I didn't say promise. Yes, it's asynchronous. Yes, I mean promise of that thing. Okay, so now I will implement it. All right. Get page image. So we're going to do something very simple to begin with. And that thing that we're going to do that's very simple is we're going to make the prompt just the content of the page in the book. That's it. I mean, this is like a really simple version. So let's start with that right now. So book, and remember this is zero based. So book is an array, page number is the page that this is referring to, and we want the content. So whatever is written on the left side of the app here is going to be the prompt. This is the most rudimentary way to do this, but it gives us something just to get going, okay? The next thing we're going to need to do is we need to create the image model. So I'm just going to say image model equals new replicate, okay? And then I'm going to give it a few parameters. I'm going to give it a model, and that, by the way, I'm going to copy from over here. Actually, I'll copy all of these parameters from this just to make sure the fiddly stuff I get right, and everybody doesn't waste their time watching me try to recreate the arguments here. But I'll explain why these are the right things here. Okay. So as I mentioned before, we're going to use the Kandinsky model. The LangChain API wants you to tell it which model you want to use. Otherwise, how does it know what to do for you? The input, one of the kind of parameters to that specific model, and actually I think to all the replicate image models, text to image models, because this is a text to image model, is the image dimensions. We're going to tell it 512 by 512 just because if you specify bigger sizes or whatever, it can be quite a lengthy run. We want to keep it reasonable. We actually would probably be even okay with the size below this. And maybe that's even one of the things we'll play with in step 3 to see if we could speed up image generation. But this third parameter here is the API key. So you need your API key, and I'm going to set mine right now because inside my Convex project, you will see I don't have any environment variables yet. I'm going to need to set that environment variable because, again, my action is running on the back end in a secure environment. So I need to specify my environment variable here. And that means in another window that you all can't see since my actual API key, I'm going to go to replicate and grab my API key. And then let's see, and then copy it into this project. So I'll try to do that quickly so you all are not waiting too long for me to pull this off. So let's see, okay. Replicate API key, okay. And then let's see what you do. Okay. All right. So as you can see, it refreshed over here. Everything Convex is reactive. My replicate API key is now in my environment. So going back to our code, I now have this image model. How do I invoke it? I just call on it. So I can say const response equals, and then await image model.call. And then the parameter I'm going to give it is the prompt, okay? And then finally, I'm going to return the prompt because, again, actually, I have it in the other order this time. So I'm having it the URL first. So in the response, by default, that is called, that is just response. I thought it was response.text, but we'll find out. If we get it wrong, we'll just log it and see. Response and then the prompt. So yeah, coming up here again, image URL, that is what we're going to get back from this model. This model is going to generate an image given this string, which is the prompt again, and then I finally want to return the URL to that image that replicate generates using this model, and then the prompt back to the caller. Let's see if that works. You know, let's would call API services. I'm going to get rid of that because we are actually calling. Got a result. Image URL and prompt. And by the way, iterating on things this way works great. So I would definitely just inch your way there, console log stuff. This just committed in the background. We're still syncing code. I'm going to get my dashboard back in a separate window so that I can see what's going on. And we can watch both things at the same time. So here's my logs right here. And let's make a change to the story again. George was a monkey. Okay, let's start having real content now. So we'll probably see one round of actions. It's outdated since I paused for a second. Yep, there it goes. And then the next round, it'll probably take a little longer to run. Oh yeah, no, it was pretty fast. Got a result. Okay. And this is getting cut off. There. Let's load this manually. Oh man, whew. Page 2 is even better. I probably should fix that. But why by default does this thing just get super super morose? Kind of cracks me up. Providing it very little prompt other than page 2 is even better. This is where image generation takes us. So I'm sure that says something. Anyway, what about the other one? Let's see what the other one looked like. The other, page 3 was empty. Oh yeah, that's something I should handle right now too, by the way. So whenever we add a new page, the content's initially empty. One thing we should definitely do is if, let's just check this real quick. If book page number dot content dot, why did that not, oh, I didn't finish. I didn't close the brackets. Content dot trim return. We don't want to bother passing empty strings to the AI services. Doesn't make any sense. Anyway, that's fixed. We won't worry about it. We'll deal with that later. Anyway, let's see what this other one was. So page 2 is useless because it was an empty string. Page 1, George was a monkey. Okay, let's hope we have something kind of like a monkey here. It's a monkey. Okay. So now, but we're not updating our app because we've got it. Now that we have this URL, we have to get the data back into the database, right? So now we go back here and we want a mutation to reflect these values. Now when we come talk about these parameters, they're going to make sense because we just spent some time talking about why we need them in the context in which we're generating them. So page number, version, image, and prompt, okay? An image is really image URL. Let's check our schema for a second. So, all right, we need to make this a little more sophisticated. The image is not just going to be null in the future. So, in Convex, you can have a union and then list the different types that it is the union of. So similar to TypeScript, it's perfectly okay to have a field be either one type or the other one, and Convex will type check everything and just make sure it is one of those things or the other one. It can't be any random thing, but it is okay to make it either one, and then your code will just make sure you kind of check for both, right? So that kind of a pattern works just fine in Convex, and so let's do that. So it's either going to be null, which is what it is right now, okay? Or it's going to be an object, and that object is going to have two fields, URL, which is a string, URL, which is a v.string using Convex type system, and then the prompt, which is also a v.string. Okay, there. Okay. This is probably actually why we were having that error back in the first step, is I just shorthanded this to v.null, and the TSX file was like, I'm pretty sure that image is null. And so it didn't give it credit for having these attributes on it because I hadn't specified this in the schema yet. So I think that explains those type errors I couldn't make go away in the very beginning. Okay, cool. So we've got image. It's either null or it's this object with a URL and a prompt. No errors, everything's pushing up, schema validation looks good. So let's type these just so we are all happy. Number, version is a number, image URL is a string, and prompt is a string. Again, mildly annoyed at Prettier for not cleaning this all up automatically, but let's just keep going. Okay. I'm just going to make this slightly easier for me to visually parse here. All right. And then this isn't going to return anything. It's just going to have a side effect of updating the database. So what do we need to do here? Well, we got to do this. So we generated the image. Now we want to commit the image information for that page to what the AI service came back with. But we have to make sure it's still the same version. So let's do this. If the version that the action was running under is still equal to the version current.version, it's still the same version of the book. Let's go. It's time to update. So once existing equals, and we'll do something interesting here, okay? db dot query chapters dot with index, and this is going to be pretty similar to the one we saw before. By page number, nope, not creation time. I want that autocomplete back. There we go. And specifically, we want the document where page number is equal to the given page number. Now, you might think we have to, I didn't match my parentheses, there you go. You might think we have to make sure this exists, but we absolutely don't. And the reason is we're making sure the version of the database is the same. So even if they deleted the page, we wouldn't have effectively an index error here when we try to find this page number, because the version of the database wouldn't be the same if the database had changed. So we're technically not covering things like clear table and stuff like that. But in general, when mutations are done, we're going to make sure we update the version number. And so this doc will exist, and not only will exist, but the contract we have with this version number is it will be exactly the document we think it was, which is this is the document, and all of the other documents as well, all of the other pages are the same. So this existing, it is real. It does exist. So we can unconditionally just say db.patch, and let's update the image. So existing.id. And we are going to say image. And our type checking here should now let us specify a record that, and it maybe give us field on complete too, which is URL, yep, is image URL, and prompt is prompt. Okay. If it's still the same version, update the document. Should we just log so that we don't go crazy? Not updating database. AI action was for outdated book version. Okay, let's log it just in case the long-running action comes back and we decided not to update. Cool, okay, maybe this is all good now. This is not happy. Oh, because it thinks it might be null. Yeah, but it's not. I mean, not for a reason that type system can understand, but for one that we are, with our model, making sure is true. So, okay. Convex function's ready. That pushed up successfully. So now, oh, we need to run it. And then maybe we're done with step 2. Let's find out, okay? Okay. Hopefully you're going to start to guess how this works, but instead of run query, we're going to use run mutation. We're gonna bring that in as well from the context. We got a result, and we're going to call run mutation, and it's asynchronous, so we're going to await it. This should autocomplete update chapter image, okay? And then we should be able to type check our way to success. Page number, that's the same. Version, that's the same. Image URL, yep. And prompt, yep, okay. I think that's everything. I think maybe we're done with step 2. We're gonna find out maybe now. So George was a monkey. George was a little monkey. Let's follow along. in the dashboard and make sure we don't see any errors. Outdated. Ooh, got a result. Oh, let's go look at our, look, image, prompt, and a URL. Ah, our app updated. It's a monkey. Great. Okay, page 2 is even better. We're back to bleakness. Oh, man. Cool. Okay, first step is done. AI content is being integrated into our storybook. I mean, it's kind of awful, but it is happening. The one thing, let's hook up as a bonus before we go away, is I really love this button to regenerate image because sometimes you just don't like what you ended up with. And for one image, you want to just kind of kick it off. And so let's make that happen. And tell the scheduler dot run after 0. Let's just run it right away. And chapter regenerate AI populate page image. It was going to want the version, isn't it? Yep, and we're going to need that. We'll grab this again. Version doc. All right. Okay, and that's a wait as well. All right. Okay, if the page exists, just go regenerate right away. Yeah, there we go. Okay, let's try again. Yeah, there we go. Cool. All right, it should have kicked off the action right away. We'll get another funky monkey image back. Taken a little while to generate this one, but the action hasn't failed, so. Yep, and this was the call that was made by the action, get book state with version, so it's still running. Yeah, one thing just to set expectations with you all is, yeah, there we go. That's lovely. Oh, by the way, yeah, there's the title text. I said if you hover, we can see the prompt. These services are pretty slow, and sometimes they time out, and sometimes you'll suddenly run out of quota on your token, and you have to log in and figure out why. Just be prepared when especially when you're iterating on them and hitting the services a lot. In a minute, you're gonna occasionally cause something weird to happen. It'll take a long time, or it'll time out. You'll get a 429 error. That one in particular, OpenAI is known for. So be prepared. Have a little patience. Yeah. So cool. So where are we at here? We have an app using AI. It's a full stack app. It runs a background action that goes and fetches a generated image from a AI service that it has a text to image model inside that service, provides that as a API call. And then it updates the app, and the app automatically refreshes because we mutate the database to reflect the URL of the generated image. We also are doing a little bit of kind of debouncing and version tracking to make sure that because this thing can take many, many seconds to generate, we're not accidentally putting the wrong image into a newer and updated book. So that's a big step forward. From here on out, step 3 is actually really just about refining this and a lot more about AI thinking and a little bit less about kind of general systems and backend and full stack thinking. So what we're going to do next is one of the observations I want to make to you all is this. This is really the key insight. And in fact, we could even say something like this. Okay. So while these images generate, one of the things that you should think about this version is that this is a terrible prompt, right? So George went to the zoo. The problem is by the time we get to this panel, nobody knows who George is. the text to image thing. If we think about the way books are usually constructed, we build context on characters, and we build context on scenarios. This is can see that as we say George went to the zoo and he went home and went to sleep, George is now a boy here. It's not clear who George is here. Of course, George is a monkey here because we say George is a monkey, right? So the context of the story is not being persisted in each of these scenes. And so even though we're introducing some AI content, these prompts are pretty weak because they're not giving the text-to-image model very much information about the appropriate illustration that should occur in this spot. The good news is that we can make this way, way, way better. And this starts to get into what the focus on step 3 is going to be, which is prompt engineering. Okay, so in the next step, what we're going to do is we're going to bring everybody's new best friend and life partner into the picture, ChatGPT. And we're going to work with ChatGPT to basically have ChatGPT help to like read the story and summarize the right illustration instruction for any given page. And so by doing that, we can get ChatGPT, we can sort of coerce it and massage it into providing us a pretty good prompt for replicate and the text-to-image model. So we can say to ChatGPT, and you'll see that this is kind of exactly what we do, I would like you to read this story from page 1 to page 2, and then I want you to make the appropriate illustration on page 2 using contextual information about the characters from earlier pages, right? And when we ask ChatGPT to do that, because ChatGPT is fairly amazing, ChatGPT, it does it. And so it provides, kind of pretty reasonable prompt for the text-to-image model. And so this is going to get a little into the idea of model chaining, right? Which is exactly kind of where things like the LangChain terminology comes from, is often the richest way to use generative AI is to combine models and make the output of one the input into another, and then you're going to end up with just a much better result. So in step 3, I'm going to take one more water break and come back, and in step 3 we'll dive into doing some prompt engineering here and doing some chaining in order to make this app a much better version of what it is. All right, step 3 is where things get really interesting on the AI side. So we've got all our system stuff out of the way. We're syncing stuff to our backend. We're automatically updating our app whenever anything changes. We're making sure that we do rate limiting and throttling of AI services. We're making sure that the images are always consistent with respect to our ever-changing storybook. All that's good. So from here on out, we just stay in AI.ts in kind of that action file where we're doing interesting things with AI, and we just get a little bit more sophisticated about the way we think about how the generative stuff is working and how we bring multiple models together and chain them, and also kind of spruce up their prompts a little bit to make things work a lot better for our app. So let's talk through some of this chaining stuff a little bit conceptually before we start writing code. So we have a chain, right? So a chain is almost like a pipeline, and LangChain is all about chaining things. And in theory, it can chain all kinds of things, but the ones we're going to talk about today again are like prompts and models. And so right now, all we're doing is, let's just say that this right here is a model, right now what we're doing is we're just calling this model directly in our code. The first kind of chain that LangChain kind of introduces to you that you probably encounter first is a chain between what they call like a prompt template and a model. And so the idea is that when you specify a prompt template, you can specify some context around the prompt, right? So you can have kind of like a preamble, and then you have like a variable, right, that's inserted, and then you have like a, some kind of like prologue or something, right? So something that goes after. And so the idea is you kind of create a template, and then every time that when you combine these things together, a model like the one we made and a prompt template, you create a chain that people are, what's the way you actually use it is you're passing in parameters each time of a specific input variable, and every time it's inheriting the kind of contextual information about the rest of the prompt, right? The first version of this we'll do actually is we're going to make our use of replicate a little better by introducing a prompt template, and we're going to just make a really simple prompt template, right? That spruces up our prompting just a bit. Let's dive into the code, and I'll kind of show you what that first step looks like. One more time here. I'm pretty sure I'm in the right project directory, and we're in step 3 in all places. So let's pop up our storybook. We should still be in the same state. George the monkey, George went to the zoo, then he went back home to sleep. This is our same pretty disappointing and bleak version of the story that we kind of had before. So this is, ostensibly the scenario here that we're working through is like a children's storybook. We're having a pretty simple story. Obviously, George, I'm vaguely curious, George, like, this is a kid's story. So let's modify the prompt to try to see if we can get a consistent kind of like almost like visual language between these different images. Some of you may be familiar with like in the style of, and so the first prompt template we'll do is not including this prefix part, but we'll say sort of like, input variable and then space in the style of a children's book illustration. So let's make that change to the way using LangChain and see what it does to our images. So back in AI.ts, let's make this nice and big here and take a close look at get page image. The first step in this, or the first change we're going to make in this third step, right, this final phase of our project here together, will just be completely inside this function. So let's just juice up our use of LangChain a little bit. Let's make a prompt template. Prompt is not going to be this anymore. So let's say once prompt template equals, and this is going to be a new prompt template from LangChain, and it is going to take a template, which is the actual template, and it's pretty simple in this case, prompt description. I actually want this to be page description in the style of a children's book illustration. Okay, and then input variables, and LangChain wants us to say page description is one of the variables. Okay, then we still have our same image model, and now we're going to make a chain. Image chain equals new LLM chain. Yes, and we're going to say prompt is the prompt template, and LLM is the image model. Okay, and now instead of calling the image model directly, we're actually going to call the image chain. And it's not going to be given the prompt, it's going to be given const page description equals book page number dot content. All right, so we're still not really enriching the content description very much, but we're at least going to see if we can consistently get the style to be similar. Okay, so then the response that comes back from this chain is just going to be called text, and so the URL is response.text. Now, here's one thing to acknowledge in this current setup. The prompt is actually going to be the formatted output of this prompt template. That's really what we want to return as the prompt. So the page description is not quite right. We could say like prompt template dot format and then give it the input variable, which is page description. We can do that for now. I will say this is a little heavy-handed. The fact that we have to, this is a wait, I believe. The fact that we have to call this explicitly rather than get this as an output out of this chain. But all I can tell you is for right now, this is okay because we're about to make this will all get a lot smoother in the next step when we start involving a more sophisticated chain. We'll be able to capture the actual prompt into the image model without having to kind of re-invoke the template manually. So ideally, we'd be able to intercept the step in this chain, and you actually can do that, but it just involves some awkward steps that we'll just gloss over for right now. So let's just manually fill out the template and see what this looks like. So now that we have this new thing and it looks like it's uploaded successfully to our backend, technically we should be able to hit regenerate image, and then we'll see if we have a bug or anything. Prompt is not defined. Interesting. Okay, line 46. Oh yeah. Okay. So it's not prompt, it's page description, right? Yeah. Oh, why isn't autocomplete liking me there? I don't know. Okay, it's not prompt anymore. We're passing along a variable that's populating this prompt template. So we're calling the chain, which involves both the template and the model, and then this is going to pop into here, and then therefore anytime we invoke this chain, it will be in the style of a children's book illustration. So let's kick off this image generation again since the previous one failed. And looks like it's running in the background. Hey, we got a result. Check it out. That's pretty cool. That looks more like a children's book illustration, right? Like, that's great. That's exciting. The fastest way for us to kick off all these is to make a small change here. George was instead of little monkey, let's just say George was a monkey. And then we're not clearing these on mutation yet. So even though these actions are running in the background, we don't know. That's a bug fix we'll have to do. But we should see the images redraw. Yeah, check it out. And he went home and went to sleep in the style of a children's book illustration. Oh, look, it's like a children's book illustration. George went to the zoo in the style of a children's book illustration. Neither of these know George is a monkey. We still haven't solved the problem about contextual information from earlier chapters, but we are at least having something that does look like children's book illustrations. It's getting closer to more stylistically consistent, which is kind of cool. Great, that's a pretty big step forward. While we noticed it, let's go fix the problem. I lied about having no more systems-y thing to do. We don't need to mark image null here because what we are going to have to do is update await db.patch, and then we're going to say pages i.id image null. Okay. Why are we doing this? Because since we're kicking off regenerating all the pages of the book whenever any page changes, we should mark them all null right away so that we get the spinner back, right? So I wired this up just to regenerate a single image. So if we regenerate this, then we'll get the spinner here because it nullifies the image in the back end, but not here or here. But if we, there you go. Okay, wow, that's George went to the zoo. That's what it looks like. But if we come in here and say dog, we're regenerating all of them. And see, now we're accurately reflecting the fact that there is some background processing going on. So we feel good about this. George went to the zoo. George was a dog. There's a dog. Sure, then he went home and went to sleep. It's kind of a sweet image. Look at that. And that's kind of a face. Cool. And that's kind of a trunk. Anyway, this stuff cracks me up. Even that's like kind of a dog. It's sort of like dog melded into floor a bit, but we love it. Okay, great. Well, that step forward was pretty easy, right? So that's our first introduction to this kind of flow. This is a chain. Now, it's a pretty simple chain, right? We could have like done our own string interpolation or whatever, variable substitution. So, it's kind of moderately convenient that LangChain does this for us, but it's, we haven't yet got to the juice of what's kind of really cool about some of this stuff. So the next move we want to do is we want to get ChatGPT involved so that we can generate better prompts that involve contextual information about the characters from earlier in the book. So in this new setup, what we want to do is we want to have another prompt and another model. Okay, so another prompt template and another model. This is GPT, and this is not stable diffusion, but yeah, so the replicate model we're using, right? Replicate. This prompt template is the one that says it's not including this beginning part here in the style of. Okay, so this box is its whole thing, right? This is one chain. This over here is another chain, okay? Chain and chain. So the next thing we're going to do is there's something called a sequential chain. I'm just going to put sec chain. And it lets you create a chain of this to this. You can connect output variables of this chain into input variables of this chain. Why do we like that? We like that because we can use the absolutely amazing ChatGPT to ask it to basically create a great summary of page 2 based on earlier chapter contextual information, describe the characters, and it will do that. And then we can take that and say that in the style of a children's illustration, and then we'll get much better stuff out of this. And our book and the generative AI images within it will persist the idea that George is a monkey or George is a dog on all the pages where George appears, which is, if you think about it, pretty damn cool. So let's work on pulling this off. So, all right. So we'll go back to our, as promised, we're going to live in AI.ts and just make things a little richer here. So instead of this being get page image, let's change this to get image chain. Okay. And then actually, let's keep this here and just create a separate. Okay. This actually doesn't need any information. And it doesn't even need to be asynchronous, I'm pretty sure. But we're going to have this be an LLM chain. And we're just really going to carve out part of this. The part that's not about the instance we're invoking, but the part that's about kind of describing how the model is used, right? So in theory, if we reorganize our code, refactor it like this, and we just say const image chain equals get image chain, like this, I think we are still working, other than we lost this prompt template.format. So let's mock that out for right now. All right, let's run in the background. LLMChain. Oh, thank you, types. It's probably the same error I've got down here. We'll pop that back up. We need to actually return this chain. I'm losing track. There we go. Okay. Yes, yes, maybe. Yep. Okay, cool. So it should still be working. We'll let that generate in the background, but I'm going to assume it's going to go. Yeah, in fact, it did. There's another dog. Cool. Okay. So in the spirit of this part is good. Now let's work on this part. So hopefully in a not shocking turn of events, we're going to call this get summarize chain. Good enough. And we're going to have this be another chain with a different kind of template, right? And using a different model. So we need to get, we not only are going to use replicate, we are going to use, so let me grab this, chat models, OpenAI, chat OpenAI. So we're going to use chat OpenAI, and then we are going to also use some different prompts. So the chat prompt template, those things are out of, let's see, LangChain prompts. Port from LangChain prompts. Chat message prompt template and human prompt template, system message prompt template. Okay. Cool. All right, so working with the chat model is like a little different, but it's also pretty straightforward, to be honest. And I did some prompt engineering here, meaning kind of iterated on things until I got something that worked. So let's look at the prompt first. So this is this left side here of the chain. So const prompt template, just like the previous function for images, equals, and this has multiple parts to it. We're going to give it a series of messages. And the first one is, actually, we're just going to give it one to start. The human message. So for those of you who haven't maybe operated at the API level with these chat models, there's a few different roles one can take when you talk to ChatGPT. So if you go to the website and you just chat with it, the role you're taking is like user or human, and it means sort of like the entity that's having a conversation with the agent, right? But there's a couple other roles. One is called the system role, and it's used for it's used for setting up context about the conversation. So sometimes people use the system role to say things like, you are a French explorer, right? And so like then when someone says like, hey, how are you today? Then ChatGPT might say, well, I can't wait to go visit the Alps, and or something, right? So the system message is a kind of almost side channel to inject like a personality or a context into the conversation. The human message prompt is this is the actual message that's being said that expects a response. And then there's other roles like assistant, which is almost like you can give it a hint, like here's an example of an answer that is appropriate for what this person's going to ask. And then that way, when the human asks the question in that form, it gets an especially good answer, right? So there's a few different things in the mix. We're really going to start by, we're just going to do the human thing, which is like, this is literally like what we want to type to ChatGPT. And so this is the template I came up with after doing some iteration. And I think kind of in the bonus territory is if folks grab this project and want to play with stuff, absolutely iterating more on all of this is definitely one of the areas where like you can make a lot more progress than I did. There's just so much you can do here to keep trying things and to basically make all the chain of models generate stuff that's better and better, you know, given whatever your goals are. There's a real art to it, and it's pretty fun, honestly. So I just copy and pasted this, and I'll read it to you all so that we can think it through together. So I say to ChatGPT, or we're saying collectively in this project, ChatGPT, I'm going to tell you a story. Each paragraph is a page in a children's book. There are 3 paragraphs in total, representing 3 pages. Here is that story. Then this is the variable book paragraphs, right? And in this place, I want each page separated by a blank line, right? To each one is a paragraph. And in my experience, ChatGPT successfully understands when the story ends in this format, right? Where the story begins and where it ends. And then I say, can you please provide a brief description of the scene that occurs on page X so that an illustrator can draw it? This illustrator has not read the book, and so they do not have any context on the scenes, plot, or characters. Please include details about the appearance of the characters in this scene so the illustrator can accurately represent them. So this is the prompt to ChatGPT. Now, one of the things that's interesting is I had a version of this once where I included all the pages, and that actually sometimes misfired because, and this gets into some of this fun subtlety about the way this stuff works. If I ask them to draw page 2 and I include page 3 in this paragraphs that they read, sometimes something would appear in page 2 that it wasn't possible for anyone to know yet. And in fact, you kind of didn't want them to know because as part of the story is that something was going to change. And so what I found to be the best, and we'll implement this in a minute, is to give them, every time we're generating an image, let's say for page 1, if it's for page 1, only give them page 1. If it's for page 2, give them page 1 and 2, and then ask them to generate it for page 2. Basically, don't include details from the story that haven't happened yet. You'll also notice it says a brief description of the scene that occurs on page 2, right? The reason why it says that, I actually had a version of the prompt once that said the final page. And ChatGPT, because it sort of has personality sometimes, because it embodies the personality it's ingested, it sometimes would say funny things like, you asked me to summarize the final page, but the story only has 1 page. That doesn't make sense. And I would be like, fair enough, ChatGPT, right? So I actually sort of found that you could say like, the story has 1 paragraph, it has 1 page. Could you please summarize the page 1? And it more often would go ahead and give me its best shot at describing page 1, rather than like pick apart some meta thing about what I'm asking is odd, given that there's very strange to call something final when there's only 1 page. So that's why it may seem kind of silly to say page 3 when page 3 is always equal to the total number of pages, but it just ends up that seems to work the best, right? So this is in that kind of prompt iteration that you do. And there's a little bit I'm going to do together on this video after we do the first version of this. So there's a little bit more refinement we'll do as we go here. So, all right, there's our prompt template. And then let's say now we need the summary model. Remember back to here, prompt template into model. Summary model equals, and we're going to say new chat OpenAI, and this takes a few parameters, actually just 1 parameter, the API key, and that is process.env.openAI API key. This time, to spare you all from watching me do it, I just went in the background and copied and pasted my API key in. You can now see I have both API keys in my Convex environment. So this will be available to the action when it runs. So there's our model. By default, I believe this is using ChatGPT 3.5 Turbo. You could, there's like a model name thing in here. If you really wanted to override it to do ChatGPT 4 or some other thing, you could do that. But the default is fine in this case. And then it's time to make the chain. So summary chain equals new, and then we're going to say LLM chain, just as we did for images. And prompt is the prompt template, and LLM is the summary model. And then the output key is page description. All right. So these two probably look familiar to you, prompt and LLM. Okay. This is the same thing we did for the other one. The prompt is kind of the input, LLM is the output. The reason why we're labeling the output key is because we are going to chain these. And so if you remember this, page description is the name of the input variable on the next model in the chain, which is the image model. So we want ChatGPT to output its answer in a key out of this chain that matches the input key to the next hop in the chain. And that's what's going to allow us to sequence these, is they know that they connect through that parameter, basically. Yeah, so this is this. We probably have type error because we're not returning anything, and that's true. We return the chain. We now have both individual chains created here, LLM chains, and now we want to make a sequential chain to connect them together. So this is no longer sufficient. We need both chains. Summary chain equals get summary chain. Summarized chain, I guess I called it here. That's fine. Now, we want to combine these together. So the total chain, the full chain, equals a sequential chain. I don't think I have this imported yet. This is from chains. Import sequential from LangChain chains. Yeah, let's try that now. Sequential chain. Yes. Okay. Sequential chain. All right. Time to hook these all up, okay? Chains. First thing first. This is an array. It's not a set. It's because it's in order. We're actually specifying the pipeline here, right? So the summarized chain goes first, and then the image chain consumes the prompt that ChatGPT is generating. So it's not chains, chains. Then next, the input variables, okay? These, what we're gonna say here is, it's kind of interesting. Book paragraphs and num pages, okay? The reason is those are the inputs to the first chain in the sequence, summary chain, right here, num pages, book paragraphs, right? So therefore, it's the input to the entire pipeline, the entire sequential chain. Then output variables, okay? This is where it gets kind of cool. Remember I said we're gonna be able to get our prompt out more cleanly. So image URL, page description, okay? The image URL, there's one change we need to make here if we want both of these things to come out, which is we're going to name the output key so that it's just not called text or something like that. Let's give it something that is a better label. Okay, so the output key of the final hop, the image chain, is going to be called image URL. But we are also hanging on to page description. We're including that in the output variables because they don't collide, which is actually the output out of the earlier chain, the summarized chain. And this is how we'll end up with both the prompt, which again we want to retain so that we can see what happened, and we want to make it the title text, the title property and everything. and the actual URL of the final image. So I think this is all the pieces. And yeah, so now we need to get our variables. So this is no longer the page description. The page description is being calculated, right? So what are the inputs to this? Book paragraphs and number of pages. Okay, so let's make into code the things I mentioned a minute ago on the stream here. So the subpages are the pages of the book between 0 and whatever this page number is plus 1. So if it's page 0 that we're supposed to summarize, then we just want page 0. If it's page 3 or index 2 we need to summarize, then we need 0, 1, and 2. So then we want everything through 0 through 3 basically exclusive on the slice call here. Then finally, so we're going to say const book paragraphs equals, and then let's do subpages, and these are pages. So let's say .map, given a page, we want the content, and then we're going to join by 2 new lines. So if we do this, then for every page in this array, we're going to return an array that is only the contents, and which is a bunch of strings, right, of each paragraph, each page, and then we're going to just put some space in between those, an empty line. And yeah, so that's our paragraphs. Const num pages equals subpages.length. Hopefully that also makes sense. We're going to tell ChatGPT that the book is, this many pages long. We're kind of lying to ChatGPT because we're hiding future pages, but it doesn't matter because it just makes everything work out okay. And then finally, we need to call the chain. So overall chain.call, book paragraphs, and num pages. And then what do we get? The response object is going to have the output variables on it, right, from right up here. So we're supposed to return, if I look at the function signature of this, it is return a promise of string. Well, that's really helpful. Image URL prompt. Okay, URLs first. All right. So response.image URL and response.page description, which is effectively the prompt. This is the output. One more time, this is the output of the last link in the chain, which is the image generation. And this is the output of the first link in the chain, which is ChatGPT summarizing the page, which effectively is the prompt, the input into the second link of the chain. It really makes sense to probably switch the order of these things. And since that would make sense, let's do it. Let's do it now. Okay. All right. Then we need, yeah, we're going to reverse these as well. Okay. All right. So we reverse those. Probably all good. Cool. Will this work? I don't know. We changed a lot of code, but looks right. No errors. Everything's syncing successfully to the back end. Let's see about the first page. And we're probably going to want our console up because there's a good chance we've got a bug the first time. Although it's running for a little while without erroring, so maybe it's right. So another good time to remind everybody, these models take a while to run. In particular, once you've got ChatGPT sitting in front of the image generation, you're probably going to find the runtimes go up. All right. Look at this. And let's see. Okay, check this out. This is what ChatGPT said. On page 1, we see a full-page illustration of George the dog. George is a medium-sized dog with short brown fur and big floppy ears, sitting perfectly still, looking straight ahead with his tongue hanging out of his mouth, and a look of pure joy on his face. There's no background or setting in the scene, just a focus on George's adorable appearance. Love it. It's so good. All right. What if we say George was a monkey who lived in the big city? So exciting to see the quality go up. And then I'm going to make a duplicate of this so that we have another copy open here at the same time, because we're going to do some cool tricks. Since we changed the text, it's regenerating all the pages and probably doing an absolute ton of computation. It hasn't errored out yet. That's good. So we're going to have a refinement to this in a minute that will make this a little faster. Yeah, okay, good. We got some results coming back. Yeah, okay. What do we have? Okay. George is a monkey who lived in the big city. There's a monkey in a city. George went to the zoo. Look! George is seen standing in front of the monkey enclosure at the zoo. He's looking up at the other monkeys who are swinging and playing in the trees. The other monkeys are different colors. They say other monkeys, a red t-shirt and blue shorts with a curious expression on his face. So one of the things I will say that's very interesting in terms of this ingesting the human knowledge is there's sometimes if I say things like a monkey who lived in the big city, I'm pretty sure that ChatGPT starts kind of leaning into this is Curious George. And so it starts describing other characteristics about George that are not just a monkey named George that sound actually more like Curious George. So it's very interesting that that kind of emerges out of this process. And you can see when he went home and went to sleep, we once again see George is surrounded by, George is a small brown monkey with a curly tail. So we've maintained the idea that this is a monkey. And so very hopefully when we hit dog, both of these re-render because there is new contextual information that changes the later story. And after we wait an insanely long time for this to run, oh, check it out. George the dog is in bed now. Let's see. Let's see the prompt. Well, I have to switch things. Looks like this one's taking a little longer to run. Hopefully it didn't error out. George went to the zoo. George is a small, scrappy terrier with floppy ears. I like he's a terrier here. The giraffe is tall and slender. Now it's interesting that the text-to-image model couldn't make anything out of scrappier terrier with floppy ears and a wagging tail. And then this one is taking long enough. I'm a little worried it might have had an error. Although I don't see one. When's our last error? Not for a long time. 12:20. Oh, no. Yeah, I think this one did fail. So this is what I mean about when you're doing this, you're probably going to find that sometimes the services just have an issue. They're under a lot of load. A lot of people are really into AI right now. They're going to fail for various reasons. That's part of why I made this button is occasionally if you just have one page that has a problem, wait a few seconds and kick off the job again. There's a good chance it's going to work the second time. There we go. George's dog lived in the big city. It's a dog in front of a city. So the one I mentioned, one refinement we'll do together to this, just to give you a taste of the prompt engineering, is part of what makes this a little flaky in my experience, and sometimes you end up with wacky stuff like maybe here, is that, and this is, let me say this with the camera on me because it's very, a very cool observation, right? Is ChatGPT is too good, actually. And so what happens sometimes is ChatGPT kind of waxes poetic about stuff. George is, it injects meaning into George's intentions, and there's this expansion of George's characteristics to fit the tone of the scene and all this kind of stuff. Basically, like, sometimes it's just a lot of text that comes out, and it's very flowing, it's very expansive, and you're like, wow, that's really impressive. But like, I wrote a sentence, I got 3 paragraphs out. Unfortunate side effect is even though a human reader loves reading this, it confuses the heck out of the text-to-image model. So the text-to-image model really likes, like we did when we were experimenting, it likes a short prompt that's fairly, descriptive about exactly what's happening. That doesn't include too many adverbs about how it's all being done and all that kind of thing. It tends to get a little lost the more that there is. And so that's part of why it's so interesting sometimes to look at these prompts. And then you can go into this big thing you got going on, and you can play around with different parts of it. And so the one thing I was going to do that mostly I've found there was a small change that seemed to have something of an impact here is when we go to our summarization chain, because again, it being so capable, there's a lot to do on the ChatGPT side to make things better here. So instead of just this human message, let's inject a system message. And one I found that was kind of worked pretty well is to tell ChatGPT from a contextual perspective, you are speaking to an 8-year-old. Provide your answer in simple language using at most 1 to 2 sentences. Is something like this. And if you say something like this to ChatGPT as kind of contextual information, then the prompts just come back more compatible with the level of sophistication that the text-to-image models like. So let's go, instead of a dog, a monkey. What if we make a cat? George is a cat who lived in the big city. Oh, I lost my, there we go. So let's kick off this one more round with the new code that's including the system message, telling ChatGPT to like chill on the kind of expansive language. Okay, so all right, so it's a little shorter. The scene on page 1 shows a gray and white cat named George sitting on a windowsill in a city apartment building. The background should include tall buildings with lit up windows and maybe the moon or stars in the sky. I like the maybe. Use your best judgment, model. And then George went to the zoo. Okay. George the cat is seen walking through the zoo. In the background, you see other animals in their enclosures, such as lion and monkeys. George is a black and white cat with fluffy fur. And that's in there because we prompt, right, ChatGPT to say, hey, you need to describe the characters because, like, the illustrator doesn't know, hasn't read the book, right? Curious expression on his face as he explores the zoo. So we do, I'm guessing this is George the cat, or maybe this is George the cat. There's lots of cats. So the text to image didn't really get they got kind of the cage, but not really maybe the animals in the cage, but there's all this hints of like the right thing without quite doing it. George went home and went to sleep, and now we have a sleepy cat. So George the cat sleeping in his bed. George is a gray tabby cat with white, but the bed is circular. So the more ChatGPT gets a little literal and just instructive about telling the text-to-image model what to do, the better everything turns out. Short and like to the point about what to draw. So there's still a lot of room for improvement on this, like to just make the prompt simpler and simpler and better shaped as the way a human would do it, so that you're really being pretty succinct about the description of what the image should show. And as you can see, we're always persisting in the style of a children's book, right? So we're always having this kind of illustrative style that looks appropriate for a children's book. So it's actually pretty cool what just even a little work in this file, ai.ts, does to refine your way towards something that works, reasonably well as a first cut. So this is step 3, and now with that, we're done with step 3. Here, hopefully you all found that kind of informative, and if it's the first time you thought about this stuff or played with it, I hope it was useful. All this code is going to be in a GitHub repo, including this exact thing I built with you. Each of these steps, I'm going to check them all in, and so you can kind of take a look at the finished product for each step and see how I kind of inched my way there. If you all have any questions, you should jump on like the Convex Discord where you can find all of us. It's at convex.dev. There's a link to the community, and we're happy to answer any questions about this project in general, even the parts of it. If you're building on another stack that doesn't have anything to do with Convex, great. We'll still do our best to see if we can answer the AI parts to the extent that we understand them. Or just leave comments below and all that kind of stuff, and we'll follow up on those too. I did kind of write down a step 4 for like left to the reader kind of a thing as a few things you might think about doing next. Because this is still a pretty simple, flawed project in many ways, to just illustrate the basic point, right? So one is better error handling, right? So right now, if the action fails, we don't retry the action. And so I have to manually click regenerate. So there's definitely some engineering you could do around kind of rescheduling failed actions. If something goes wrong on the calls to the APIs, you don't want to just break the book forever. So you probably want some way to recover that. And that could be one of the things you dig into fixing. There's a lot more prompt engineering, like I mentioned. I think another one of the big things is you could swap out different models. Like instead of ChatGPT, you could use kind of a completion model and see how well it could do, like DaVinci or something like that. I haven't tried it, but there's a possibility to both speed up the process quite a bit using a almost simpler model that's not as chat oriented, and you maybe wouldn't get as much noise in the prompt, like on page 4, and in things like maybe, maybe include, the cat being curious or whatever, right? That maybe is probably not doing any, is not probably helping the text to image model at all make any sense out of what is being asked of it. There's also, even just tweaking parameters to make the generation faster and playing around with the difference between responsiveness and quality, right? So I really haven't changed any of the defaults on the way that these models run other than the image size. So that's another thing that could probably go a long way. A lot of better looking UI kind of things. You'll notice there's a little flicker when I change the text. I'll switch back to that to show that for a second. So then he went home and went to sleep. He went home and had a party. So there's a little brief flicker when I hit enter, and that's because I'm not using optimistic updates on the client yet. So it temporarily reverts back to the server value until the server propagates the saved value that I just submitted. So there's little UI things like that could be polished. And then probably the biggest fatal one that you don't notice in the short run, but it basically makes the app completely broken, is when replicate or really or Dolly or any of these things generates an image, it only provides that URL ephemerally. So you're really supposed to fetch that URL and store it in your own location. Oh, there we go. The cat had a party. What did it say here? Wearing a party hat, surrounded by friends. Yeah. So when those images are generated, you're really supposed to fetch them and put them in your own image or object store and serve them. So with this book, pretty frequently, if I kind of mess with it and I go away for 24 hours, when I come back, all the images are broken because those AI services they only keep the images up there for a short period of time. So Convex has storage, for example. You can easily fetch the actual image data down and go put it into a convex file storage or something. So, or put it in S3 or any other storage location. So yeah, that's another change you could make to it that would make it more like a real app instead of kind of a toy that's demonstrating the concepts here. But yeah, so if you grab one of those or you grab something else, you do something interesting, this swing by to the comment section or whatever, and let everybody know what you did. That's it for today. Thank you all for watching. It was a long video. Hopefully there was good stuff in there. And until next time.